Okay, let's start by talking about the exam tomorrow. So the exam is tomorrow, and it's the same. You'll follow the same procedure that you did for the pre-test. You will go to PSA 21. You show up anytime between 10:30 and 6:30. So at your whatever your schedule allows, and then you can work as long as you want. But then they take all the tests and kick you out at 8. Okay. So just arrive anytime between 10:30 and 6:30 with a sun card, and then you can work as long as you want in the exam. Okay. So there's multiple choice, and there's a kind of a shorter written part. Okay. But again, don't let the format of the test determine how you study. You got to understand everything really well. Okay, so the test is reflective of what we've done. It's not going to be now a bunch of algebra problems and a bunch of exercises. It's going to be testing your understandings of the meanings of things and the reasoning that we've been using. So if on Blackboard, again, go to Quiz and Exam. The Quiz and Exam, I have a folder there called Exam 1. It's got everything that'll be on there. It's kind of a bullet point list. And then I've posted, like end of last week, I posted the solutions and point breakdown for your first quiz and recitation last week, and a blank version of that quiz. Okay, so that's all really good to help you studying. In assignments, so anything I've assigned for homework is fair game. And one particular assignment, that bar diagram assignment that was due on the 28th, there was that one. So I have that, I posted this a while ago, but just to remind you that the full solution is there too. Okay, but anything that I've signed for homework relates to that bullet point list, and then you've got the quiz, and then the videos. Okay, so a good way to study with the videos is to pause, think about what we're talking about, create a good set of notes for a video. Okay, find a way that you can watch it sped up a little bit, and so you can be more efficient. Okay, speed it up to like 1.5 the time. Does YouTube allow you to do that? Certain videos? I got to figure out how you can do that, because that's really helpful. Yeah, I got to look into that, because that will be very helpful for you guys. Anyway, so videos, the quiz, and solutions to the quiz, and all the homework will all be really helpful for studying. Question?
You said we can take as much time as we want.
Yeah.
So the test on time?
No. You just have to be out there by 8. So if you get there right at 6:30, you've only got an hour and a half. Okay, but if you get there in the middle of the afternoon, stay as long as you want. No time limit on the exam. Other questions? Make sure you have your sun card. Okay, you can bring a graphing calculator. You will not need your laptop with graphing calculator, although there's a good chunk of it about graphing calculator. Either I'll ask you to create command lines for a certain that you want to produce a certain situation, or I'll give you command lines and ask you to interpret what's going to happen. Okay? So graphing calculator is important. Why? Because it's all driven by the mathematics that we're learning anyway, right? It's all driven by the math that we're learning. Other questions about the exam? And that's in the bullet point list, right? Should be. Yeah, graphing calculator, representing functions, graphing lines, functions, points, utilizing sliders. Okay? Yeah, sorry.
Did you say that there was any specific hours that you'd be there for a short time?
Oh, I will, let's see, tomorrow's Thursday. I'll be stopping in and out, but I don't have a block of time that I'll be there. But I'll be stopping in and out. And then, so then tomorrow, recitation. If you're on Thursday recitation, you should go to recitation, and you can study or work on the handout that I'm going to give you, which is questions 1 through 5. Those in recitation yesterday already got this handout. The rest of you will get it today. So numbers 1 through 5, which are good practice for the exam, will be due Friday in class. It's a shorter assignment. You should have no trouble with it. So for recitation tomorrow, you can work on this, or you can study for the exam, because it's before the center opens. So no one will have taken it yet. If you're in Tuesday recitation, you want to show up to get help, I will be there. Mercibel, is she here? No, she's not here on Wednesdays. She'll be there, so if you want extra help, anyone can show up. But if you're in Thursday recitation, you should go. And then I also have office hours tomorrow from 12:30 to 2:15. which still gives you plenty of time to take the exam after that. So plenty of chances for you to get help from me tomorrow after you do your last part of your studying tonight, right? Everyone's already done most of their studying, and you're going to tie it all up tonight and bring your questions tomorrow. Okay. Yeah.
You said that for the exam, you said that the office hours weren't changed, and then also the recitation. What time is the Thursday's recitation?
9. It's 9 at the same place. Same time, same place, but on Thursday. Yeah. Same room, 9 a.m.
Are you going to be there?
Yeah, I'm going to be there tomorrow. I'll be at recitation, and I'll have office hours. So you got to study and figure out, half the battle of studying is figuring out what you don't know, right? Don't assume that you understand something that you don't. Figure out what you don't know, and then get those questions answered or have those conversations with me. The best way to study is to have a conversation with me, because I'm going to find where your deficiencies are, and we're going to get that ironed out and get your thinking aligned with what's correct and makes sense. Okay, so that's the best way to study, is to dig in on your own and then have conversations with me. And I'm giving you lots of availability tomorrow. Okay, other questions? All right, so how about the homework? So let's turn it in. Let's not fold this. Let's not fold this packet. If you did already, sorry. Heading, name. All I need is your name on this. All I need is your name. If you have other things, it's okay. You don't have to erase them. So just name upper right corner without folding. And let's talk about it. Okay, just open it up and write your name upper right. Okay, if you're, this homework will just be based on completeness and presentation. Okay, completeness and presentation. So if you gave it an effort, you tried, and you show me some professional work, your grade will be fine. Do I have them all? More. Do I have them all now? You just sit there in the corner, I'll come get a litter. Yeah, right there is great. Okay, so let's go over this. So you have this function, and we define that function, okay? And so now I want to graph it. So I'm going to put in y equals a control t, right? And this is going to graph the function, right? Okay, so what is the function of t in the first line? What is the purpose of t, or what role does it play in the first line? So all it is a placeholder. It's called a local variable. All it is hold the place of the input. There's nothing special about t. We could have used b, we could have used c, we could use any open parameter in graphing calculator that's not reserved for something else we could have used, and it would be the same thing. So now, what's the purpose of t in this one? Is it the same? What's the role of t here? What's that? Yeah, now it's a parameter, okay? So now we're just throwing t into this equation, and so it's a parameter. And so if we haven't defined what it is, what is it now? It's 1. So what will this do when I hit graph? What kind of line?
Just a straight line.
All lines are straight? You mean horizontal? That's right. Okay. So we're just going to get a horizontal line somewhere. So what do we want to do to graph this function? We want all the values of x and the corresponding values of y according to that rule. So we want x. Okay, that's a pretty good picture of it. And now we have meaning in the context. So what values of x make sense that we want to see?
0 to 110.
That's right. So we go 0, less than x, less than 110. And that gives us the part of the graph that we want. Okay, how about so we want to do a moving, go ahead.
Is there any way we could actually fix our x-axis and y-axis instead of using the shift things?
So the zoom,
Yeah, like
Yeah, that's the only way.
That's okay.
Yeah, but you can do them separately. You know how to do them separately, right? Yeah. Okay. Yeah. So the only way to zoom in or out is, or to change your axis scales is using the zoom button in the lower left. Okay. Okay. So how about the movable point? So how do we graph a point? So if you want a point somewhere, we need the control 2, and this is a vector. Okay. So this is a vector, and if you just put values in there, is it control shift 2 for Mac or for PC?
No, it's control or shift. You can go to go up and down, just the axis.
Oh, okay. All right, so now I've plotted a point at x equals 60, y equals 10. Now if we want a movable point on the graph, we can use n and use a slider to change the value of what temperature on the x-axis, and then say we want the corresponding value of expected attendance, so we want a point that moves on the graph. So if we want a point, again, we're going to do control 2. And so if we want to control the value of x, we can use our n slider, and so that will be the value of n. And if we want all points on our curve, or points that give a corresponding expected attendance, then what do we want here? So yeah, so a of n, right? A of n is kind of the way we say it. So control 9. So try to, whenever you're defining functions, use control 9. And if you forget, lots of times it'll know what you mean, but just to be safe, always use control 9. So let's do a red point on there. Okay, so now I'm going to just do a black point. So now as I change the value of n, we'll get that point on the curve. Now we want, so now I'm showing all values of n from 0 to 10 by tenths. So what do we want? We want to go from 0 to 110. And if we want to show, I'm going to show, so to show every 5, you guys figured out that your steps was 22, but I'm going to show every 1. Okay, I'm going to just go ahead and do it for every 1. That way, if I hit play, it should work. What's going on? No worky worky. What's going on here?
Did you mess up the end values?
Yeah.
No, I didn't do anything wrong.
Yeah,
Just not happy. I can't even grab it now. Yeah, it's just not working. Let's save this. Let's see how many else I got opened up here. Desktop. Okay, so something got stuck. So there we got our movable point, and I'm changing n from all the way from 0 to 110. Any questions so far? So we wanted to draw this triangle, and we kind of related that quickly to our conversations about rate of change, constant rate of change, that we can show a change in temperature and a corresponding change in expected attendance. And that has everything to do with what we're talking about with constant rate of change. Okay, so so we'll do one, say starting at 10. So if we want, let's graph it here. Say we want this right here. Okay, we want to, from this point, we want to show a change in temperature of, say, 20. And then we want to show when you have that change in temperature starting at 10, the corresponding change in attendance. Okay, I know this is different than what was on the assignment. So now a change of T of 20, and then we want to show the corresponding change of attendance of A. Okay? So this segment there is really what? What is that? Where's that come from? It's just a horizontal line, right? So it's just a horizontal line, and we just need to know, so is the horizontal line a y value or an x value? All right, so we just need to know what y value that is. Y equals what? Okay, it's a function value. It comes from the expected attendance, in particular, when the temperature is 10. So y is a of 10. And if we did y a of 10, what will we get? We'll get the entire horizontal line, right? And if we just want this part of it, then we want starting at 10 to 30. If the change in t is 20, then from 10 to 30.
What is that little symbol? The delta?
Where?
In between 10 and 30?
10 is less than x is less than 30.
Oh, that's right. Okay.
Yeah, it's
I'm sorry.
no problem. Is that better? No, that's worse. That's like an asterisk. Okay. All right. Similarly, this one. So what is this? This is now a vertical line. Is that an x value or a y value? An x equals. So where does that come from? X equals what? That's x equals 30. That will give the whole vertical line, and we want it just from a starting y value here of a of 10 up until a of 30. So yeah, so it starts at a of 10 where our horizontal line was, and we want that thing to stop at this height, which is, that's the y value when the temperature is 30, or a of 30. See, so notice we can define this function up above, and then from there on out. So this is why we spent the time on function notation, because it's really useful, it's really helpful. We don't have to sit there and crank out a of 10 and then type in some decimal approximation here and crank out a of 30 ourselves. So we've defined the function, now we use it. So we can use that notation. It's really helpful, and that's why we took the time to really focus on understanding function notation, how to read it, how to use it. Okay, so if I put in those command lines, we get that triangle. I'm not going to do it, but... So if we put that command line in, and that command line in, those will give us our two segments that will form this triangle, quote-unquote triangle, that represents the delta t of 20 and the corresponding delta a to that delta t. Questions on that? Yeah?
Did you do that on separate command lines, or is that the same one?
Yeah, you got two different things. So you got two different mathematical elements. So two different mathematical elements will require the two different lines. Yeah. Yeah. Other questions? Yeah.
Will that triangle move when you move the slider?
Okay, so this triangle moves when we move the slider.
No.
Why not? Nothing to do with n. So when you move the slider, what are you doing? You're changing the value of n. It's n changes. What changes here? There's no n in it, right? So none of these things will change as you change n. Similarly with this, if you change the value of n, nothing changes. So that triangle is just fixed there. So now that's what we want to do next. We want to have a moving triangle. So in the moving triangle, we just have any point. We just start with any point here. So don't look at what it is. And its x value is what? N, right? So we want it to, the x value of that point to be whatever we choose it to be via the slider. And so then what's the y value of that point? N. Okay, so that's the coordinates. So we want, say, and you guys did what? A delta t of 10? So wherever that ends up. Okay, so it's a delta t of 10 still. And then the corresponding delta A. But now instead of starting at the point 10, A of 10, we start at N, a of n, and then when we change n, it'll change the triangle, right? So that's just the mathematics behind it. So same thing now. We're going to start with this horizontal line. What is it?
X equals n.
X equals n. What do you think?
Oh,
Yep.
I'm sorry.
That's okay. So what is it?
It's y equals n.
Y equals n.
Oh, and then you do like that.
Y equals n?
A.
A of n.
Can you explain why is it?
So n is our x value. See, n is going to take on different x values. You see? Yeah, so this then, that horizontal line is at the y value corresponding to n.
Yeah, I just gotta look at these.
Yeah, that's right. Okay, so where does it start?
N
Starts at n,
to
and we want it to end at
x, n plus 10.
n plus 10. See, this is how powerful function notation is, having a slider and having parameters that can change, right? Change variables are, and function notation is really useful in creating something that represents something meaningful, okay? So now we want this is x or y value? That's an x. What x value is it? N, is it n?
It's n plus 10.
This is n plus 10, right? This is the x value of n, and we want 10 greater than that. So now x is n plus 10. And
It's a of n to, oh, it's between a of n
A of n.
and plus 10.
so a of n is the lower bound on that vertical line. And the upper bound is, so is it this or this? Those are two different things. First or second?
Second.
We'll do first thing in a second. So if you do a of n plus 10, then what will your delta a be?
It'll be a of n.
As I change n, what will delta a be?
Well, it'll be a of n plus 10, like number 10.
Yeah, so our a of n is the bottom, and we're always going to make that thing 10 tall, right? So then that thing will always just be 10. This will take the function value at n plus 10. That's what we want, right? That's what we want. Okay, so let's put it in. So we want y equals a of n. Yeah.
So like instead of like saying 10, we wanted to put like any value, like theoretically, could we put like delta t like on our notes?
Right, so you could create another slide. If you wanted a different change, you could create another slider that could control that change. And instead of 10, you'd be putting the value of that slider. So then, yeah, so and you can make it work. So then you can change that slider to get a different, and then if you change n, it'll give you the triangle with that delta that you chose. Yeah, so you can do that. That's great. Yeah. All right, x equals n plus 10. A of n less than y less than a of n plus 10. Okay, did I put in what we said? And what pretty color do we want our triangle to be? Purple. Great. Okay, and this should work if we did everything right. Let's zoom in once, make this a little bigger. So there's our two command lines, and as we change n, we get it. Questions so far? Anybody have a question?
Can you go over the first command line again?
This first one?
Yeah.
So the first one, is that giving us the horizontal or the vertical segment?
The horizontal.
Horizontal, so that's a y value. So what is the y value? The y value is the y value of this point. And we know that point is n a of n, right? The
Yeah.
x is n,
Right.
the output is a of n, so that's our y value. And so this horizontal line is all values such that y equals that y value of that point, or y equals a of n. Okay, and then we want to start it here. That's a starting. What x value does it start at? Well, it starts at n.
Right.
And where does it end? n plus 10 because we're forcing that change in temperature to be 10.
Right.
So it's going to end at n plus 10. So it's going to start at n. We want all the x values between n and n plus 10 of this horizontal line. So you have to get that part right there.
Okay. Makes sense.
Better?
Yeah.
Okay. So then the very last thing on the sheet was what happens? You go over the top and it's gone. We still got a nice horizontal segment, but the vertical segment is gone. Okay. What's going on here?
The value of n plus 10 is less than the value or the value of a of n plus 10 is less than the value of a of n. There's no range for y to be.
Okay, so he's talking about where's the value of a of n right now? What's the value of a of n? That's here, right? And where's the value of a of n plus 10? Above it? So a of n plus 10 is now here. So the value of a of n plus 10 is here. You see? And we're instructing it. What are we instructing it? All y values that are what? Greater than that, above that, and also all y values that are what? Less than that. What y values are those? What y values are greater than a of n and also less than a of n plus 10? What y values are there? None, right? There's none. Because we need both. We're saying, give me the y values that are greater than this one and also less than this one. So greater than this one and also less than this one. There's none. So it does what we told it to do. It shows us none. See? So how can we fix it over here once we get past where the function starts to decrease? So all we need is one more command line. We still want it to be at n plus 10, right? But how can we define? So we want the y values, we want these y values right here. How are we going to get those? Zoe?
We could switch it, like exactly what it says in the line above, but the less than or equal to signs would be going the other way, so that it would be greater.
So normally when we write these, we always use less than. So can you do it using less than? What would it be?
It would be less than or greater than the a of n plus 10 and less than the a of n.
Right. So reading that from left to right would be the lowest value is a of n plus 10 is less than y is less than a of n. So now this is finding all y values. Your starting value a of n plus 10 greater than that and also less than a of n. Those are the ones we want. Okay, so over here, the first line that we put just doesn't show anything. It's a valid mathematical statement, and graphing calculator is obeying it. It's giving us every y value between above a of n and less than a of n plus 10, which is none of them. So it doesn't show anything. But here, this is valid over there. Same thing when you switch it, when you come back here to these lower t values. Now, this one doesn't make any sense. It's a valid mathematical statement, but doesn't give us anything because there's no y values. But now here you're saying all the y values above a of n plus 10 and also less than a of n. So it just says undefined, meaning there's nothing that works. But now this one's kicking in. Right? This one kicks in. When you make it over the top, then the second one kicks in. Okay. Questions about, so this, what I covered here, really important that you understand how that all works.
Can you, I'm sorry.
Sure.
Can you describe the a of n plus 10, like the third line? Like I got it right, but I don't understand why. Like why?
This is back to this thing right here. So right here. Right here. So what is this saying? This is saying, this is like the range of y values that we want. This is the lowest y value. We want to include all of them from this one up to this one. So it's all y values above a of n. Well, over here, when it's a decreasing function, a of n is your high point. So above a of n, I'll do it in blue. You see, above a and n is all this.
Yeah.
And also below a of n plus 10. Here's your a of n plus 10. That's all these. So what y values are both here and also here? None. So it clicks off. Once a of n is greater than a of n plus 10, now there's no y values that work. So we got to switch it. Make sense? Okay, other questions? Okay, so we're just starting to see a glimpse of how this is a lot more powerful than a handheld graphing calculator. And there's a lot more to come, okay? All right, so the next thing I want to do is, I want to talk about number 8. So Melody had requested number 8 from the homework, the reflection. When you had reflection questions. So this was the one that, it says, suppose different cars leaving Phoenix headed towards Los Angeles at a constant speed of 57, that y be the number of miles from Los Angeles, and x be the number of hours driven that day. Which statement about the relationship between y and x is true? Y equals kx, delta y equals k delta x. Okay? So, it may help us here to set a distance. Does anyone know the approximate distance from Phoenix to Los Angeles? How many miles that is? 400? Perfect, we'll call it 400. So distance from Phoenix to LA is 400 miles. And let's think of our quantities here. Y is, and here's our car. This is not to scale, by the way. Okay, so what is the distance? What is y? Y is the distance from what? Distance from. It's the car's number of miles from Los Angeles. Distance of the car from LA. Okay, so this right here is our quantity y. And x is our number of hours driven. So let's just do some analysis here. So really, to understand the situation, it really helps to kind of get the quantities going with some values. So when x is 0, what is y? 0 or 400? So when x is 0, we haven't driven any hours yet. What is y? 400, right? 1 hour later, what is y? How many miles will I have traveled? 57. And so we'll be at, is that 343? Okay, and so just to mix it up, let's say, how about after driving 5 hours?
So it would just be y minus 5 times.
Right, so in 5 hours, we'll go 5 times that distance. So anyone got it? As soon as you get it, shout it out. What is it? 115, why? That's what I heard. Is that right? Cool. Okay. And so now let's talk also about delta x and delta y, really, because that's what constant rate of change is all about, delta x and delta y. So let's look at it. We got 3 changes we can do. What's this change right there? From 0 to 1. That's 1. What is the corresponding delta y?
57.
57. What do you think? Negative 57. Uh-oh. What is it? Negative 57. The change, when we use this change notation of delta, we want the sign of it to represent either increase or decrease. Increase or decrease, okay? Here's another one. From 1 to 5, what was our change in x? 4. What was the change in y? Someone said minus what? 285? And there's one more change we can do. 0 to 5. Change in x.
Or, sorry.
5. Change in y. Negative 2. No, change is 5. Is this right?
No.
For a change of 4, this is when x changes by 4, what should this be? 228. Yeah. All right, did I lose anybody? Understand what we're doing? So there's a difference. This is now we're highlighting the difference between the quantities x and y. X being hours driven and y being your distance from LA, which is decreasing. Delta x and delta y then are the changes in those quantities. So when x changed by 1, the distance changed by negative 57. When x changed by 4, how much did the distance change by? So what's the change from 343 to 115? Is that negative 228? Okay, and then from the change from 0 to 5 means the change in y was negative? Is that our 285? Okay, that one's our 285. So it asked, which is true? So yes or no? Does y equal kx? Meaning, can we get, is there some constant k that if we multiply it by x will give us y? That's what we're saying. Is there a k times x that will always give us y? No way, right? No way. How would you find that? You would divide y by x. So the first one you can't even do. The second one gives you 343. Third one gives you something much less than 343. There's no constant k that gives you the distance from LA as a constant multiple of the time in hours driven. What about the second one? Is there a constant k? Is there a constant k that always gives us the change in miles driven if you knew the change in time? And what is it? Negative 57. So this is no, and this is yes. Do we have constant rate of change or not? So we don't have y as equals kx. We do have change in y as a multiple of the change in x, constant multiple. Do we have constant rate of change? Some are saying yes over here. Yes is here. Are you convinced? What's the requirement? What is when we say constant rate of change? We talked about this. What does it imply? What is constant? The relative size of the corresponding changes. You don't need this to be true. Not needed. And here's an example where it's not true, but we still have constant rate of change because we have the relative size of our changes, corresponding changes, is maintained. Yeah?
Is it okay if you figure them out differently?
It depends.
Because you're going, instead of the distance you're traveling from Phoenix to LA, you're doing the distance you have left, so it doesn't.
Yeah, if you had the distance from Phoenix, it's a totally different problem. It's a different quantity, so it's a new problem.
So is that okay, kind of like explanation for that?
No, you're saying that you used this distance from Phoenix to the car?
No,
Okay.
I'm saying it was wrong because it was that distance. Like, you couldn't have done y equals kx, you had to do change because it wasn't that distance.
She's saying what you said in a separate way. Y equals
Without
kx is
doing all
wrong
the numbers.
because the distance from P to where you're at isn't the distance being measured in the formula. It's just a different way of saying what you just said.
Yeah, but what you said was kind of backwards. We're given the situation, and then we're analyzing to see if y is equal to kx or if delta y is equal to delta kx. So it's not. So
So you want us to do all that math?
I want you to understand. I want you to be able to
Conceptually.
do it. So yeah, you got to be able to understand this whole conversation. Does that answer it? Yeah, you need to understand what's going on here. But it's not like so the situation governs whether this is true, whether this is true, whether they're both true, whether neither are true.
I understand that,
Okay.
but I made the proof that the top one was false because it wasn't measured in a different way. Like if you measured it from Phoenix.
I don't understand how you can make a conclusion about these quantities by using a different quantity. I don't get that. So you're talking about the distance from Phoenix. So if you're using the distance from Phoenix,
Well, I said that's why that's wrong, and it has to be a change because you're doing LA instead of Phoenix.
let's talk about it later. I'm not connecting with you. Sorry. Okay. All right. Any questions about this example? Okay. So let's have a PowerPoint that we can summarize this. Before that, no, let's do this. I'm going to take roll, and I've got 7 different implications of if y varies with a constant rate of change with respect to x. I have 7 implications, most of which we've talked about, a few that we haven't. I want you to get a partner and try to brainstorm as many as you can come up with. If y varies with a constant, my task is to figure out where they are and see if I can find the right one when you call them out. Okay, Ryan I gotcha. Nicholas, you're up.
I said delta y equals k delta x.
Okay, changes in y are a constant multiple of changes in x. That's huge. I mean, that's maybe the one we'll use the most, okay? Where is it? Not there. Let's see. I think it's this one. No. There it is. These are pretty dark blue. Okay? That's definitely one of them, and that's a really important one. Okay, Jonathan. Jonathan, no. Tell me another one.
I said the changes in y are proportional to changes in x.
Yeah, that's kind of the. Oops. Yep. Definitely. That's where the math. That's what the mathematics all spills out of, right? So that's the idea of it. The change in y are proportional to change in x, and all the mathematics flows out of that. Okay, Gilbert, you're up.
Y changes with respect to the change in x.
Y changes with respect to the change in x. Okay, Matt, can you say it a different way? I'm not. Or do you have another one? Did you think?
No, I haven't written down.
Okay. Bowen, did you get one? A different one?
Average change in y is average change has the same size relative.
Okay. Relative size. Let's see if that's, yeah, this is this one. Relative size is maintained, right? Relative size is constant. Hey, you got the first 3. You got the first 3. Okay, Linwin. You got another one?
Change in y is simultaneously.
Change in y changes simultaneously. Okay, so how does it do that? Yeah, because yeah, that's this one here. Yeah. Do you have another one? No. Okay. Cool. Where's Stephen P? Stephen here? Yeah. Did you get another one?
No, I didn't get anything. I got those.
All right. Let's take volunteers. You came with someone else. Chloe.
Like graph will be a straight line. When the graph.
Linear relationship. Yep. That's one we haven't really talked a lot about, but yes. Volunteer. Who got a different one? Yeah. Chloe. Zoe.
The X and Y change simultaneously.
So there's lots of ways X and Y can change simultaneously and not be constant rate of change. So that's just all covariation, that X and Y change together. This is a very specific way that X and Y change together. Sterling.
You can swap them out, so X will vary with the constant rate of change with respect to Y.
Say it again?
You can switch.
Oh, you can switch it? Yeah, okay. So if Y varies with constant rate of change with respect to X, then X also varies with constant rate of change with respect to Y. That's true. It's not on my list. That's true. Peter.
The graph will have a constant slope.
Okay. So let's put that on this one. Yep. That's what, and that's kind of saying the same thing over again. It's linear, it has constant slope. All right, so we're kind of running low, so I'll just show you that. Whenever X changes by 1, Y changes by K, or Y changes by K per unit of X. All right, so whenever Y changes by 1, whenever X changes by 1, Y changes by K. Does that make sense? So that's the change of Y per unit. K is the change of Y per unit of X. That's another way of saying that. K is the change of Y per unit of X. So when X changes by 1, Y changes by K. Okay, this is the one we were talking about for the first time on Monday. Y always changes K times as fast as X changes. So this is the one where we can relate constant rate of change to the quantities Y and X. This is the way that Y and X change together. Okay, Y always changes K times as fast as X changes. So it's the one where we have we can relate it back to those original quantities Y and X. And then the last one is actually number 2 in your handout. So I'm going to leave you in suspense and have you think about it. So those who did not get the handout yesterday in recitation, or you need another one, get this on your way out. It will be the numbers 1 through 5 will be due Friday. And you have your exam tomorrow.
Will you be there the whole recitation or just
I can stay a little longer. Yeah.
Yeah.
Anybody else need a handout? I know it's the same one I gave out yesterday, but lots. Numbers 1 through 5. That's right. Good. Anybody else? Oh, thanks. Thank you. Yes.
We will take a screenshot of this details accommodations.
Okay.
And send it to you because this is stuff that you need to fill out.
Okay.
But actually review the possible for this week.
Okay.
It's not going to affect this test, it's just for future tests.
Are you going to do testing center tomorrow?
Yeah, and it's for short notice, we need to ask.
Okay.
I'm completely understand.
Yeah.
But for the future, what I want to try and get out is
Sure. So the next time you guys meet for office hours, then we'll just go through. It's like an email, right? And we just.
it's a form online. So
Online
I'm just
form.
going to take a picture of it and send it to you guys. You can just send me back.
Okay.
And then what it does is they forward it from me back back to you after it's completed
Okay.
for your approval. So if there's any notes afterwards, or something changes, you can change it and send it to the testing
Okay.
center.
Yeah, I think if we're sitting down together and doing it, I think we can do it all
We should,
without
I
that.
just don't know
Without
if I'm gonna be able to make it in, that's all.
yeah. No, I'm just saying in the next couple weeks.
Yeah.
Yeah. Okay, sir. Anybody else need questions? Let me turn this off. Hold on.
Testing center situation?
Yeah.